Hello, it's a pleasure to be with you today at the International Summit for the Storage of Renewable Energies. I'm sorry that I haven't been able to be there with you in person, but it's still a pleasure to spend some time with you today. We are in the midst of a very profound economic crisis. And now that economic crisis is giving rise to an even more profound environmental crisis. It's no secret that fossil fuel energies have now matured. Coal, oil, natural gas, heavy oil, tar sands, coal, these energies are getting more expensive. They're never going to get cheaper again. They are in their sunset stage. And now the technologies that are based on these energies, like the internal combustion engine, centralized electrification, are antiquated. They've lost their S-curve, as we say. There's very little productive capacity left in them. And this entire civilization we live in is made out of carbon. Petrochemical fertilizers and pesticides for our agricultural production, construction materials, synthetic fiber, pharmaceutical products, power, transport, heat, and light. So we're at a stage now where the industrial revolution based on fossil fuels has now led us to a profound global shutdown of the economy. At the same time, this industrial revolution has now given rise to a more profound environmental crisis, climate change. After 2 centuries of an industrial way of life, where we've spewed massive amounts of CO2, methane, and nitrous oxide into the atmosphere, we now face the prospects of a transition, a turning point in the actual chemistry of this planet. Climate change is now in real time. And what's so terrifying about climate change, which isn't normally talked about, is that it changes the entire water cycle of the Earth. We're the watery planet, and we live off our hydrological cycles. Those cycles have emerged over millions of years, and the problem with climate change is for every 1 degree that the temperature goes up on this planet from climate change, the atmosphere absorbs 7% more precipitation from the ground. It just sucks it up because of the heat. And that means we see an entire shift in the water cycle of the Earth in 1 moment at a time. We're experiencing more bitter winter snows, more dramatic spring floods, more profound summer droughts, more hurricanes and tsunamis, more volcanoes, and extreme weather. And now this is impacting both agriculture and infrastructure. The fact is that our ecosystems cannot catch up to this change in the water cycle, and so our ecosystems are destabilizing. And the plant and animal species in these ecosystems are now being threatened with extinction. Our scientists tell us on all the scientific models that we are now in the 6th extinction event of life on Earth. We've had 5 wipeouts of life on this planet in the last 450 million years. And every time there was a mass extinction event, the chemistry of the planet shifted quickly, a turning point. On the average, it took about 10 million years to recover the biodiversity after each extinction event. And now our scientists say that with climate change, we are now actually in the 6th extinction event, and we could lose up to 70% of all the species of life that currently inhabit this planet by the end of this century. So the question is, what do we do? The industrial revolution based on fossil fuels is now on life support. It's dying. And we have a global economic crisis with more unemployment and the rising cost and the standard of living. And now the economic crisis has given rise to a climate crisis which now threatens the ability of the human race to survive in the centuries to come. We need a new economic vision for the world. It has to be compelling. We need a new economic game plan for that vision, and it has to be deliverable. And it has to move as quickly in the developing countries as in the industrialized nations. So we need to step back and ask the question, how do the great economic revolutions in history occur? If we know how they occur, we can get a roadmap of how we need to proceed. If we look back at history, the great economic revolutions come about when new energy regimes emerge. New energy regimes make possible more complex civilizations. But it's the complexities of these new energy regimes that they then require new communication revolutions agile enough to manage the new energy regimes. All throughout history, when communication revolutions merge and converge and manage energy revolutions, it changes the economic paradigm. It changes our temporal spatial relationships. It changes our consciousness. It changes society. Let me give you two examples. 19th century, we had a convergence of communication energy, a first industrial revolution. We went from manual print presses in the 19th century to steam power printing. So this was a very big leap forward in communication. We could mass produce volumes of print material very cheaply with low transaction costs, just like the internet revolution today. Then we introduced public schools. We created a print literate workforce with the communication skills to manage a very complex coal-powered, steam-driven rail transport industrial revolution. We could never have organized that first industrial revolution with an illiterate workforce. Second example, 20th century, another convergence of communication energy, a second industrial revolution. Centralized electrification, the telephone, later radio and television, became the communication media to manage, coordinate, and market a dispersed auto and oil era, a suburban society, a mass consumer culture. That second industrial revolution, after a century, is now dying, and we can feel it all over the world. We are, however, right now on the cusp of a new convergence of communication energy, a third industrial revolution that could possibly get us out of the door in time to move to a post-carbon era in the next 30 years. We had a very powerful communication revolution in the last 25 years, the personal computer and the internet. And what's interesting about the internet is the way it's organized. I grew up on centralized communication, radio, television, newspapers, and magazines, and they are organized to be centralized top-down, one-to-many communication. What's interesting about the internet is it's organized rather to be distributed and collaborative, and it scales to lateral power, not vertical power. So today we have a third of the human race, 2.5 billion people, that are sending their own audio, video, and text, collaborative, distributed, with far more lateral power than all the television networks in the world. And we did all of this in 20 years. The World Wide Web didn't come online until 1990. 20 years later, a third of the human race communicating with each other at near zero marginal cost. But that's only half the story. What's unfolding now in Europe and beginning to move in China, Asia, and other parts of the world is a convergence of this new distributed collaborative communication revolution with a new energy regime. So the internet, which is distributed, collaborative, and laterally scaled, is now converging in Europe with a new energy regime that's distributed, that is organized collaboratively, and that scales laterally. It's a perfect fit of communication energy. Distributed energies are energies that are found in every square inch of the world. Elite energies, coal, oil, gas, uranium, they're only found in a few places. They require huge military and geopolitical commitments, massive capital, and they have to be organized centrally from the top down. And we have to scale all the economic activity vertically in centralized top-down factory production, logistics, etc. Distributed energies, they're found in everyone's backyard. The sun shines all over the world every single day. 45 minutes of sunlight can power this world with ease for an entire year. The wind blows across the planet 24 hours a day, and if we harness 20% of that wind, it gives us 7 times more power than we'll ever need for the economy. Underneath the Earth, we have a hot geothermal core of energy that can be converted overnight to energy for our use. In the rural areas, we have agricultural and forestry waste that can be converted back to energy. In the coastal regions, we have the ocean tides and waves coming in every day, a source of energy. We have enough of these distributed energies in some frequency or proportion in every square inch of this planet to provide for our small species till kingdom comes. The European Union has committed itself to a 5-pillar third industrial revolution. I was privileged to develop this plan with the European Union. It was formally endorsed by the European Parliament in 2007. It's working its way through the European Commission and in the member states. And I should say Germany and Denmark are in the lead on this revolution, but other countries, France and others, are following very quickly. Pillar 1, the EU has committed itself to 20% renewable energies by 2020. That means a third of the electricity of Europe has to be green. That's not a suggestion, that's a mandate. Every region has to do it. Pillar 2, how do we collect energies that are distributed, that are found everywhere? Well, at first we thought we'll put in some big solar parks in the southern European countries and maybe some wind parks off Ireland and some hydro parks off Norway, big parks, and then send that electricity to everyone else. None of us oppose that. It's easy, it's quick, but it's not sufficient. We can't run all of Europe just with concentrated uses of what are essentially distributed energies. So this led us to Pillar 2. If distributed energies are found everywhere in Europe, why don't we collect them everywhere? Buildings, buildings, buildings. We have 191 million buildings in the EU, homes, offices, and factories. Buildings use the most energy. They create the most CO2. The second major cause of climate change is industrial-induced beef production and consumption in animal husbandry, which we never talk about. And the number 3 cause is worldwide transport. But buildings are number 1. We have 191 million buildings in Europe. The goal is to convert every single existing building in Europe to your own personal green micropower plant, to harvest sun off the roof, wind off the side of the buildings, geothermal heat coming up from under the building, convert the garbage anaerobically back to energy in the kitchen of the building, etc. Pillar 2 jumpstarts construction. It's going to require millions of jobs, thousands of small, medium-sized companies and large companies converting the entire infrastructure of Europe, every building, to a power plant. And here's the analogy. In 1970, we had a few mainframe computers, centralized, expensive, a few companies sharing information. Then Steve Jobs came along and a young generation in Silicon Valley. They created the personal computer, the internet. And now today, a third of the human race can send information to each other with more power than the major media of the 20th century. Similarly, today, as an analogy, we have a few power and utility companies in every region of the world. They generate power. They send it to us, we buy it. But already in Europe, we have several million buildings that have been partially converted, producing a tiny bit of green energy, green electricity. In 10 years from now, tens of millions of buildings will be producing their own green electricity all over the world. And in 20 years from now, several hundred million buildings, existing ones and new ones, will be producing their own green electricity. And the reason is the phase-in on renewable energies is exponential. It's following a similar cost curve that we saw with a shift from mainframe computers to desktops and cell phones, where the technology got cheaper and cheaper, and eventually the cell phones were so cheap we virtually give them away. You buy the service. Similarly, the harvesting technologies for renewables, now solar and wind, pretty soon geothermal, hydro, and biomass, they're going to get cheaper and cheaper. And in 20 years from now, they'll be as cheap as cell phones and desktops today. And then, of course, the sun off your roof is free. The wind off the side of your factory is free. The geothermal heat underneath your office building, they're all free. So just as information now is free, now that the infrastructure is in, or nearly zero marginal cost, I should say, we're going to see the same thing with energy. So, Pillar 1, we're shifting to renewable energies. Pillar 2, we're going to convert every building in Europe to your own personal green micro power plant. Now, Pillar 3. And that's why I'm pleased to be with you today. Pillar 3 is the critical pillar, storage. The sun isn't always shining. Sometimes the wind blows at night and you need the electricity during the day. With hydroelectricity, the water tables can be down because of drought. These are intermittent energies. We cannot move this 5-pillar third industrial revolution without Pillar 3. We have to store these intermittent energies. Now, I'm in favor of all storage technologies, flywheels, batteries, capacitors, water pumping, hydrogen, all of them. We need to bring on every storage technology we can. And the people assembled in this room today, you are at the frontier and you are going to be the ones that are going to bring us Pillar 3. And without it, we can't move ahead. Let me just use one example, hydrogen. I could use a number of them. Let's say that You have a solar collector on your roof. It's generating some electricity. If you don't need some of the electricity, you take the surplus electricity, put it in a tank of water. The hydrogen comes out of the water into a second tank. When the sun isn't shining on your solar panel, you can simply convert that hydrogen back in a fuel cell to electricity, and you have a good storage medium. All the storage technologies have to be brought online very, very quickly. Pillar 4. This is where the communication revolution converges with the new energy revolution to give us a nervous system for this infrastructure. We're going to use off-the-shelf internet technology and IT technology and convert the transmission lines and power grid of Europe and hopefully the world to an energy internet, a distributed smart grid, so that when millions and millions of buildings are producing just a little bit of their own green electricity, storing it in these various storage mediums, just like we store digital in media and digital form. And then if you don't need some of that electricity in any given time of day, you can program your own home energy unit so that you sell your green electricity across an energy internet from the Irish Sea all the way to the easternmost borders of the European Union. Just like we create information, store it in digital, share it online. Pillar 4. Pillar 5, transport and logistics. Electric vehicles are here now. Fuel cell vehicles are going to be here in 2015. We'll be able to plug in our vehicles wherever there's infrastructure, get green electricity, or sell our own back to the grid. Let me say that these 5 pillars alone are just components. They're meaningless. If you just have storage alone, or renewable energy alone, or the energy net alone, or the buildings alone, or transport, they're meaningless. They're components. It's only when we connect these 5 pillars that we create a general purpose technology platform, an infrastructure for a completely new economic paradigm, a great leap in productivity and efficiencies, and moves us off carbon-based global warming gases at the same time. We don't want to make the mistake that President Obama made. Unfortunately, he made a mistake. He wanted a green economy. He spent billions of dollars of U.S. stimulus money on a green economy. It didn't happen. And the reason is he spent the money on standalone, isolated pilot projects. He'd finance a hydrogen experiment in one state. He might finance a battery factory in another state or a solar factory in a third state, unconnected. What he didn't realize is that the great economic revolutions require communication and energy revolutions to merge, surrounded by the appropriate storage and logistical infrastructure. In Europe, we've understood this. You know, we put in the feed-in tariffs, and we are getting a lot of players trying to produce green energy, and they are. Several million individual sites are now producing a small amount of green electricity and sending it back to the grid. So Pillar 1's been moving quickly, but unfortunately, we haven't moved Pillar 4 quickly enough, which is the energy internet. So we have this old transmission grid that's centralized, servo-mechanical, only goes in one direction, leaks 20% of the electricity. This old transmission line can't manage all these new energies coming in from renewable sources. So we're having very difficult times with peak loads, base loads, and surges and blowouts in the system. And then, of course, Pillar 1's been so successful with green electricity that we now have regions of Europe that are 20, 30, even 70% green electricity. But we haven't moved Pillar 3 storage quickly enough. So we are losing 3 out of 4 kilowatts. The renewable energies are coming in, they're intermittent, and because we haven't put the storage online and scaled it, we're losing 3 out of 4 kilowatts. That's why I say without Pillar 3 storage, we cannot move to a new economic era in history. And finally, our transport and logistics companies like Daimler and Nissan, they're very worried because they're putting out their electric vehicles and fuel cell vehicles. But if the rest of the infrastructure isn't in place, the vehicles are orphaned and they'll be dead in the water. So what I'm saying here today is this third industrial revolution is a great leap forward. It's power to the people. Literally and figuratively, we can now take internet communication, which is distributed, collaborative, and lateral, and use it to manage energy, which is distributed, collaborative, and lateral. We can store it now with the appropriate storage medium, these energies, like we store media and digital, and we can change the paradigm. It's going to be absolutely essential that all of the storage industries in this room move quickly online. We have to provide incentives. You know, we've had feed-in tariff incentives. We need the same kind of feed-in tariff incentives for storage, not just for energy. We need to provide a common set of protocols, regulations, and standards for all of these storage mediums. We need to make sure that every community that brings on renewable energy accompanies it with storage from the get-go, stage one, so we don't lose 3 out of 4 kilowatts. So I think this is a tremendous challenge in front of us. I don't think there's a plan B. The second industrial revolution is clearly dying, and we now have we're on the cusp of the technological possibilities of creating the infrastructure I've just outlined. The European Union's embraced it, and now in China there's a tremendous amount of discussion going on around the 5 pillars of the third industrial revolution at every level of Chinese society. The United Nations has now endorsed the 5-pillar third industrial revolution as well. So now we have to move from design to practice, and I would say this in closing. And I'm not saying it just because I'm with you today. Everywhere I talk around the world, I emphasize Pillar 3 storage. We really need to move this pillar quickly so that we can take advantage of the great opportunities of moving to a post-carbon era. We need to reduce the climate change on this planet. We need to ratchet down the temperature rise. We need to restore our ecosystems. We need to provide new economic opportunities. We need to have new employment for our young people. We need to create a more sustainable, humane society for the generations of the 21st and 22nd century. No task will be more challenging and rewarding than the task facing the men and women in this room today. So I wish you the best. I would enjoy staying in touch with all of the research institutions and the companies present. Many of you I already know. Bring us on Pillar 3 so that storage can be the linchpin for a 5-pillar third industrial revolution infrastructure for the 21st century. Thank you.